Okay, so number 21 from the quiz is, the table below shows some values of a function. Which of the following best shows the values in the domain when the function is increasing? So domain refers to all the what in a function. Domain refers to all the what in a function, all the x's. So when I have a table, and this one's pretty clear to see which ones are my x's, which ones are my y's. It wants to know which of the following best shows the domain values when the function is increasing. So which one best shows the x's when the function is increasing? When it talks about the function overall, think about like when it's graphed. You could, although you might not need to, but you could in Desmos put in a table of whatever those values are. Of course, I lost it now, so give me 1 second. So the table below, okay. The way that you do that, if you wanted to, or you could just like estimate where it is by hand, is hit the plus, hit table, and then you can put those coordinates in. So when it talks about when the function is increasing, it wants to know like when it's going up from left to right. So as I'm typing these in, you could see like it's decreasing right now. So I want to see where in the y's mostly it is increasing. So I'm going to do that. Sorry, every time I minimize and maximize, it like switches the order. Okay, but look at my outputs. That would best show me when it's increasing. Right here is like the turning point. This would be my vertex if this was a quadratic, which it probably is, but this is my turning point. This is when it starts increasing. So from 0 to 6 is when it's increasing. The one that best describes 0 to 6 would be 1 through 5. Okay, so pick the best option out of the 4. If we want to know all of the intervals where it's increasing, I would say from when x is 0 through 6, all those y values are increasing, but 1 through 5 is the closest. Questions on that? Questions on others? Yosina? Is it this one? Okay. So the standard form of a quadratic function, and this is our parent graph, by the way. X squared is our like most simple quadratic we could possibly have. It says identify the function from the list below that includes both a vertical and downward shift. So I could dissect all of these, right? But probably the easiest way to do it on your tests, because I have taught you like how to evaluate just from looking at it, if it's going up, down, left, right. The best way would probably be to graph your parent graph. So x squared, this is our most basic one. And every other quadratic is a transformation of our parent graph. So we want the one that has both a vertical stretch. So that means it's getting more narrow or more wide if it's vertically stretched. Class. So vertical stretch would be more narrow. Think of like if you cropped a picture and then pulled it this way, it gets more narrow, whatever's in that picture. So that's a vertical stretch. We want one that looks more narrow and that has a downward shift. So it's also going down. The best way to compare would probably be like the vertex. So here the vertex is at 0, 0. When I type in my other options, hold on, messed up a little bit. All right, this one shifts down and it is a bit more narrow. If it's hard to tell if it's more narrow or not, it's a rule that whenever the number in front of the x squared is bigger than 1 or its absolute value is bigger than 1, it makes it more narrow. So even if this was negative, the absolute value is still 2. That's still bigger than 1. That's still more narrow. Okay, so we know negative makes it flip. We want the one that is more narrow and shifts downward. So if that one was the right answer, 2x squared minus 5. The others, if I were to type it in, this one is a shift to the left only, nothing else. Option C, when you compare it to the parent function, you could see it's moving up and to the right. And option D, when you compare it to the parent function, is only moving up. So parent function's your original, everything else is a transformation of it. Okay, other questions? Riley? Okay, it says technology blog in it, right? Yes. Okay, so for this one, I'll zoom into the table in a second, but if you look at our answer options, it's different in that one equation is linear and the other one's exponential. So like this one's like y equals mx plus b. Exponential always has x as the exponent. And then just other things about linear and exponential. So then when I'm looking at this table, and I know it's going to be a little blurry, just do your best to see it clearly. When I look at this table, I want to determine, does it follow more of a linear pattern or more of an exponential pattern? So what do you think? How can I tell the difference if it's linear or exponential from a table? Okay, if it's linear, it adds the same amount each time, or subtracts same difference. So 1.2 plus 0.6 would get me to 1.8, right? But 1.8 plus 0.6 is not 2.7. 2.7 plus 0.6 is not 4.05. So it can't be linear. It just can't be. It's not adding the same amount each time in the y's. The x's are going up by 1. The x's don't really make a difference. It's the outputs where we see if it's linear or exponential. So then it's going to be exponential, but the reason why is because in exponential functions, you're multiplying to get to the next number. And if it's not clear what you're multiplying by, here's how you can test it out. To find your common factor, take a value from your table, except for like the first one, and divide it by its previous value, like that. That's what I'm multiplying by each time. See if it's consistent throughout. Like if I do 1.8 times 1.5, that gives me 2.7. If I do 2.7 times 1.5, that gives me 4.05. That is my common factor. So something to consider putting on your note card, because I feel like it was really easy when you guys did it. You guys averaged like a 70% on the test, which is really high for like a non-honors class. Even for an honors class, that's still high to average as a class overall. What I would put on my note card would be this formula for exponential function. That it's y equals, and my pen just needs to catch up a bit. Okay, there it is. This is what I would write. I'd put y equals a times b to the x. Those are for our exponential function. Y being your output, x being your input. A stands for what? Initial amount. Initial amount. And our initial amount is whenever x is 0. So whenever time is 0, because x is usually time, that's when it starts. So my initial amount then for this is 1.2. That should not be attached to an exponent. That's just my initial amount. What I'm multiplying by each time, which we figured out in the calculator, is 1.5. And that'll be attached to the exponent. So that's why for which are true, You would pick option B because it's exponential and that is the right setup, has the right initial amount and right, what do you call it? Common factor. The other options talk about whether or not it's linear or exponential, and we just talked about it. It's exponential. If I multiply by the same amount each time, it's exponential. Time starts when x is 0. So it starts at an output of 1.2 and continues to increase because we're multiplying by a number bigger than 1. Okay, good on that one? Questions on others? Bertia? Yes. Questions on other parts? And it could be the puzzle piece, it could be this one too. If this one matches your final, if you don't ask, then I guess you can.